7-14, and I've done 7-13, which again is much the same. Okay, the concepts are certainly the same. So we look at it, and 13 says a normal population has a mean of 20, which I've gone ahead and put it in here, and a standard deviation of 4. Okay, and what's a standard deviation of 4 mean? I'm going to go back to my newest favorite play toy. Okay, that means that one standard deviation, or z equals 1, would be equal to 4 in this case, right? This chart's always going to look the same. From -3 to +3, it's basically always going to look the same with standard normal distribution. Okay, the amount of the standard deviation, and remember we've calculated standard deviations, right? They're going to change, depending on the data. Okay, so try not to confuse those two. So in this case, we have a normal population as a mean of 20 and a standard deviation of 4. It says compute the z-value associated with 25. Okay, and we can use I think there's a formula in there, and go back and find that, but in any event, the formula is simply this. It's equal to, okay, and I'm going to put parentheses, the value, the x, right, the x value minus the mean, which is 20, and that is the formula. It's remember, x minus mu divided by the standard deviation. So then we divide that by our standard deviation, and it equals 1.25, right? Our mu, or mean, our x was 25 for this particular one, right? Okay, so I could have used that maybe instead for my formula. And you can look at it and you just say, well, let's see, from 20 to 24 would be one standard deviation, right? From 20 then to 28 would be 2 standard deviations. So, I mean, in this case, you could do the math in your head and say, well, that's obviously 1.25 standard deviations away. So now what's the z value then that corresponds with that 1.25? And if you remember, when you look at your chart in the back of the book on page 732, I think I had noted, what you do then is you come down on the z number, okay, that we found was 1.25, so I've got 1.2, and then I come up under the 0.05, so 1.25 is equal to 0.3944, 0.3944, and you look that up, right? Okay, and that's my new favorite toy. You can do it that way. The other way to do it is this way, right? Okay, and so I got a positive number, so I just want to come out this way and watch my z go up to that 1.25, 39.44%, same thing, right? 0.3944. Okay, whether I want to express that as a percentage or not. And this gives you such a nice visual then too of what's going on here, right? Because it shows that 39.44% of the stuff is above the mean. The data is above the mean. Okay, the mean being 20 and the mean being the center post there that we would have. Okay, so that gives us our answer for B. It says what proportion of the, what proportion of the population is between 20 and 25, and I probably ought to make that look, like a decimal. And please try to, extend these out a couple decimal points so that we know that we're getting there. Then it says C, what proportion of the population is less than 18? Is less than 18. Well, again, we might have to do a little math, okay, and I don't think I've done it here. We'll just kind of come down here and do it, but it's equal to, right, our 18 minus, 18's our x in this case, minus our mean, divided by our standard deviation. It's going to be a -1/2, right? Okay, so I've got -1/2 that, once again, I can go look up, and your charts, is in the back of the book, but 0.1915. Okay, 0.1915. Now, but where is that from? Okay, where's that from? This is where it can get to be a little bit technical, right? Okay, remember this formula is from the mean. It's x minus the mean. okay? And so that 1915, and again, maybe I can demonstrate it here, okay? So I started at the mean, but I'm going to come to a half, 0.5, there we go. 1915, same number, okay, 19.15%, okay, but that's how far it is from the mean. What I'm looking for is how far it is from down here, and actually on this chart I can do that, okay. See, my z is way down here, minus 3.4, come up to the minus 0.5, maybe I can get there. Takes a fine touch. Ooh, and then you just touch your, sorry, but you touch your your mouse just a little bit. Yeah, I'll get there. Dang it. There we go. 30.85, right? Or we'll look at it a couple of different ways. So it's 30.85% is our answer. And the other way to arrive at that is simply to say, remember we just looked this number up, but the other way to arrive at that is to simply say that it's equal to equal to 0.5 minus the number that I looked up. Okay, so I'm subtracting that 19.15% that's to the left of the mean, and that would give me my answer as well. And again, I would probably express that in the form of a percent. So there you have it. Over here I used some normal distributions to come up with some numbers, and they work. They give us the same answers. Maybe we'll mess around with those. I'm sure we will in the future. They add a little more complexity to it right now. Let's wait and get into that later.